Hi! Wondering in the word what is Pythagoras theorem? It's pretty simple. In the last video, you learned how to solve problems on areas and volumes of cones and cylinders. In this video, we'll learn how to solve problems on Pythagoras theorem. You will also learn how to use Pythagoras theorem to solve real-life problems. So what is Pythagoras theorem? Pythagoras theorem is the mathematics of triangles. Now watch this for a basic understanding of the Pythagoras theorem. Alright, so supposing you have a right angle triangle, a triangle with a 90-degree angle. Label the three sides A, B, C. It is important that you label the longest side C. The longest side of a right angle triangle is the hypotenuse, and the other sides are called the legs. Now we have correctly labeled the three sides. We are ready for the Pythagoras theorem. It says a squared plus b squared is equal to c squared. The converse is also true. If a squared plus b squared is equal to c squared, then it must be a right angle. Let's see an example. If the right triangle has sides of length 3, 4, and 5, let's see if the Pythagoras theory works. Does 3 squared plus 4 squared equal to 5 squared? 3 squared is equal to 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 is equal to 25. It works. Let's see a second example. Look at the triangle with sides 9, 40, and 41. 9 squared is equal to 81, 40 squared is equal to 1600, and 41 squared is equal to 1681. 81 plus 1600 is 1681. Also, this works. Whenever you have a right angle triangle where all the length of the three sides are integers, we say that all the three lengths of the sides form a Pythagorean triple. Let me take a moment to stress that the Pythagoras theorem only works for right angle triangles. For an obtuse triangle, a squared plus b squared is less than c squared, and if you have an acute angle, a squared plus b squared is greater than c squared, and so on and so forth. Let's see one more example. Suppose we have a right angle triangle with an hypotenuse of length 10 and one of the legs has length 7. How long is the other side? Let's call the unknown side A. Using the Pythagoras theorem, we get a squared plus 7 squared equal to 10 squared. Squaring the numbers, we get a squared plus 49 is equal to 100. If we subtract 49 from both sides, we have a squared equal to 51. When we take the square root of both sides, a squared will be equal to plus or minus square root of 51. Since a is a length, it must be positive. So a is equal to the square root of 51. The square root of 51 is approximately 7.14. A ladder of 14 meters long is placed on the ground in such a way that it touches the top of a vertical wall of 13 meters high. Find the distance of the foot of the ladder from the bottom of the wall. Now take a look at the picture. You can see that the ladder that is placed on the ground and touches the wall forms a right triangle. Therefore, we can easily find the distance of the foot of the ladder from the bottom of the wall. Let A be equal to 13 meter, C equal to 14 meter, which is the longest side called the hypotenuse, and let the unknown side be B. According to Pythagoras' theorem, C squared is equal to A squared plus B squared. Plugging in the values, we have 14 squared equal to 13 squared plus B squared. Since we need to find B, take 13 squared to the left hand side, so you have 14 squared minus 13 squared is equal to B squared. Hence, B squared will be equal to 27. To find B, take the square root of both sides. So, B will be equal to the square root of 27. Therefore, the distance of the foot of the ladder from the bottom of the wall is approximately 5.2 meters. Now that you already know Pythagoras' theorem, I encourage you to pause and solve this problem. Jane is a firefighter saving a cat that is trapped at the top of the tree. She leans her 10 meters ladder against the tree. The base of the ladder is 3 meters from the top of the tree. Now, how high is the tree? Now, pause and solve this. Alright, this is the solution. Compare your answer with this. Okay, let's take another example. Here, the distance between the two buildings is 12 meters. One of the buildings is 41 meters tall and the other is 32 meters. What is the distance between the top of the two buildings? Here again, we can use Pythagoras' theorem to solve this problem. You can draw a right-angled triangle ABC like this. The distance between the two buildings is AB and is equal to 12 meters. The difference between the heights is BC and it is 41 minus 32, which is equal to 9 meters. The distance between the top of the two buildings is AC. According to Pythagoras' theorem, AC squared will be equal to 12 squared plus 9 squared. 12 squared is equal to 144 and 9 squared is equal to 81. 144 plus 81 is 225. Therefore, AC squared will be equal to 225. 225 is the same thing as 15 squared. Therefore, AC will be equal to 15. Hence, the distance between the top of the two buildings is 15 meters. The trigonometric ratio is talking about the sine ratio, the cosine ratio, and the tangent ratio. When we have a right angle triangle, we can use sine, cosine, and tangents to figure out an angle within the triangle, or sometimes the sides of a triangle. The trick is to label your angles correctly. Always, opposite your right angle is the longest side and it is called the hypotenuse. The other two sides are called the adjacent and the opposite. And that will depend in the relationship to the angle we are talking about. So say our imaginary angle theta is down here. The side that is opposite this angle is the opposite side. The side that is next door and not already labeled is the adjacent side. So if we're talking about this other angle instead of this one, then we will label differently. The hypotenuse will stay the same, but the side opposite the angle will be the opposite side. The side left will be the adjacent side. Now, how do we use this ratio? We use this ratio by knowing the acronym SOHCAHTOA. SO stands for sine theta is equal to opposite all over hypotenuse, which is SO. For CA, the cosine of the angle is equal to adjacent all over the hypotenuse, while for TOA, The tangent of the angle is equal to the opposite all over the adjacent. Now take a look at the ratios again. Okay, suppose you are given this triangle with an angle of 43 degrees and an hypotenuse of 12, and you're asked to find S. Since it is a right angle triangle, we can use SOHCAHTOA to work out the side. Notice that X is the side opposite the given angle. Hence, X is the opposite side. Which of the trigonometric ratio do you think contains hypotenuse and opposites? Sine is right. Hence, sine 43 degrees will be equal to opposite all over hypotenuse. If you plug in the values, you will have sine 43 is equal to x all over 12. When you cross multiply, sine 43 will multiply 12 and is equal to x. If you work out this with your calculator, x will be equal to 8.18. Since you now have an understanding of the trigonometric ratios, now pause and try this one. Okay, the value of x is 7.8. Here is the solution. Pause and compare with your solution. Here is another triangle, but you're asked to find the angle theta. The hypotenuse is 5 because that's the side facing the right angle. The opposite side to the angle is 3. Therefore, sine theta is equal to opposite all over hypotenuse, which means sine theta is equal to 3 all over 5. To find theta, take the sine inverse of 3 all over 5. When you use your calculator, theta will be equal to 37 degrees. I hope you followed through this lesson. In this lesson, you have learned how to use Pythagoras theorem to solve real-life problems. You have also learned the popular basic trigonometric identities, which is SOHCAHTOA. Until next time, bye-bye.